Right, we're looking at this question for cams. It's the loci that we're looking for. So, okay, what we need to do first is to, draw out this whole thing that they've given us. They haven't given us certain dimensions. They haven't given us the dimension on this drawing showing you the diameter of the shaft, nor have they given you the distance from the wedge-shaped follower to the center of that shaft. So what we need to do is to look in the question quickly, and it says that the minimum distance from the cam shaft center to the cam profile is 20. So we take our pair of compasses, set them to 20 millimeters, and we can draw in a circle going around. It's a construction line circle, doesn't need to be dark. It then says that the cam shaft itself is a diameter of 24 millimeters. So we need to set our pair of compasses to 12 millimeters, and we can draw that in dark straight away. So there we go. There's my pair of compasses set with a 12 millimeter radius, and I'm able to draw in a nice dark circle representing the cam shaft. You'll see that in this question, they also ask you to hatch the cam shaft. So I'm going to take a 45-degree set square, and I'm going to hatch that cam shaft very quickly. Here we go. Let's just go and hatch that. There we go. There's the cam shaft hatched. Okay, it says that we need to draw this wedge-shaped follower. So we're going to start out and we look at this thing. It says that it's going out at a 30-degree angle. You see that I've already done that. And it's got a thickness of 10 millimeters. Okay, I'm just going to draw a quick construction line going across there, measure off 5 with my pair of dividers, and measure on either side of that 5 millimeters there and 5 millimeters there. Once I've done that, I'm going to draw 2 construction lines coming down at that 30-degree angle from those 2 marks that I just made. There we go. There we go. And then you can see that intersection over there. I can now take this thing and I will be able to draw a line going out at that 60 degree there, and a line going out over here. It's just a line going straight up over there, 90 degrees over there, giving me that wedge-shaped follower intersecting at that point. It also has a little line going across here, which they have put in. And then you need to measure off the fact that it says that it's 75 millimeters going to the top there, 75 millimeters. Take that from there to there, and you measure that off, and we can draw in the rest of this wedge-shaped follower. Go. There we go. And there we go. Right, that's done, and we can now get on with the next thing. The next thing that I'm going to do here is to do the cam displacement diagram. I think to start with, I'm just going to make sure that I can see that line over there. I'm going to take the minimum distance. Now you can see that circle that I drew at the beginning. That is the minimum distance from the cam shaft center. I'm going to take a line going across from there. Okay, just a construction line going across. I'm then going to start my displacement diagram somewhere out to the right over here. I'm just going to draw another little line going up there. And I then look to see what the scale is that they want you to use. It says that you need a scale of 30 degrees to 6 millimeters. Okay, so what do? I take that 6 millimeters, I multiply it by 12, because I'm going to break this circle up into 12, and I get a measurement of 72. 6 multiplied by 12 gives me 72, and I'm going to place that over there. Right, once I've got that in place, the next thing to do is to break that little line over there up into 12 equal spaces. Okay, so I'm going to take my set square. I'm going to draw a construction line coming down over here. I'm going to take a pair of compasses set to just less than 10 millimeters, normally is quite good. And I just mark out 12 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, I know that I've got my 12 spaces because I count while I'm doing that. Move the set square out the way, get your other set square in place, I mean the t-square, and now I've got my set squares working together. I can now take lines coming up here. You can draw all of these lines, but that's just wasting time. So just move it along, make a little dash on the line, move it along, make a little dash on the line, move it along. You can see where I'm linking it up over there. Make a little dash, make a little dash. So you're not having to draw all of these long lines, just making little dashes along here, making sure that you've got all of these points. And that the spacing over there, if you've worked accurately, that they should all equal 6 millimeters at the end of the day. Do that incredibly accurately because the rest of the drawing is based on that graph. So get that right, you'll get the rest of the drawing right. Okay, once you've done that, you're going to draw some lines going up over here from those points, just construction lines going up. Hopefully you can see all of that. And I should have all of the little lines going up. I can now label this thing 0, 30 degrees, 0 degrees, 30 degrees, 60 degrees. Don't forget the degree signs. 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and 360 degrees. Right, once you've got those, write them in. You'll find it much easier to work with rather than just putting like 0, 90, etc. like the textbook seems to put. I like to just write them all in over there. The next thing that I'm going to look at is writing in a couple of things that will help you get some extra marks. So I'm going to just draw some construction lines over here. And I'm going to write in rotation in degrees. In degrees. Okay, over here, I'm going to draw 2 construction lines over there, and I'm going to write in displacement in millimeters. Millimeters in small letters, that's not capital letters. Okay, I can write in over here the scale. Six millimeters equals 30 degrees. Okay, and I can then get going with drawing the actual story. All right, it says, the disc cam rotates at a constant velocity, giving the uniform motion to the wedge-shaped follower. Okay, first of all, which direction is it going in? Very, very, very important. You're wanting to look at that. And my suggestion is, draw in a little arrow to show that you are moving in that direction. Draw that in straight away. It says, it goes from 0 to 120 and it rises to 70 millimeters. So I find my 120 over there and I need to rise up the 70 millimeters. So I mark off 70 millimeters. There's the 120 and I mark off on there 70 millimeters. Right, I didn't draw that line particularly well. There it is. Okay, and it rises all the way up there. So I can draw a line going in from 0 all the way up to that 70 millimeters at 120. It then says from 120 to 210, the follower falls. So from 120 to 210, there's 210 over there, okay, and it falls down 30 millimeters. So I'm going to come across here. I'm going to draw a little line at the top there, and I'm going to measure down the 30 millimeters that it says that you need to move down. There's 30 millimeters. Go to where 210 is. There is 210 over there, and I measure down 30 millimeters. Draw a line. Just work very methodically through this. Make sure that you are getting this correct. It says from 210 to 300, the follower dwells. If it is dwelling, that means that it's not moving up or down. And I'm going to draw a line going across to where it says 300. There's my 300. So I go 1, 2, 3, lines across. And then it says that from 300 to 360, the follower returns to its original position. So I draw a line going all the way down over there. And the last thing that I'm going to do is to say what this thing is, and that is to put a little label over here saying that this is my displacement diagram. Cam, displacement, diagram. Graph. Call it a graph. They call it a graph. G-R-A-P-H. It's a bit quicker. Right. Okay. Okay. The next thing that we're going to do is we are going to transfer that information across to here in order to start doing this story. All right. You can see my starting point over there. That would be 0. So let's label that as 0. Let's just give that a 0 degrees over there. Okay. It is moving in an anti-clockwise direction. Is that correct? No, sorry, clockwise direction. I made a mistake over there, which would have caused absolute chaos in my life. Make sure that you read your question really, really carefully. So it's going in a clockwise direction. Check, check, check that before you carry on. Clockwise direction, make sure that your arrow is signifying that. If that is the case, then I need the 30 to come on this side so that it can move into that position the whole time. Okay, so I'm going to draw in some construction lines over here. I think before I do that, I'm actually just going to draw a line coming across from the absolute maximum height that this thing gets to. And I will draw a nice circle just going around at that maximum height. Wind that out there and draw in a circle. There we go. With the maximum height on it. I can then take my set square and I'm going to draw in some construction lines going across here. There. There. That one we've already sort of got in place, but I'll continue going over there. And this one, let's just flop that around and draw in that. Right, what have I got over here? Well, I've got my 0 degrees. This will be 30 degrees. This will be 60 degrees. It'll be 90 degrees. 120 degrees. 150 degrees. 180 degrees. 210. 240. 270, 300, 330, and 360 is back over here. Right. Okay, once we've got that in place, I can now start taking measurements across here. And the way that we do that, I'm going to take a line going across from where the 30 intersects with that line, and take that across. And I can now take my pair of compasses. I'm going to rotate that round to where the 30 is. Okay, so I take that and I rotate that round to where the 30 is. Make a little mark. Okay, the next one is where the 60 is. Let's just get that in place. There's the 60. Take that all the way across to that line over there. Extend the pair of compasses out to that mark over there. And go to where 60 is. Draw a little line going around. May as well put these lines in. They ask you to show all constructions. They might be giving marks for it, so don't not put them in. Make a line going across from the 90. Extend your pair of compasses out to where that is. Take that around to where the 90 is. Draw that arc going all the way around. Make a mark. Then it goes up to 120. 120 is at the maximum. We've already got that point over there. It then starts going down. Let's take a line going across over here. I'm just going to use a different color just to... There we go. And that is on 150. No, sorry, 120. Sorry, 120. And that's 150. Sorry, 150. That's right, 150. That's why the numbers are so important. It says 150. I'm going round to 150. There it is. Okay. And I make a little mark. The next one is at 180. Or line coming across. Move that down. Take that to 180. Make the little mark. Then we go to 210. Take that across to 210. Okay. I'm going to take this and I'm going to take that round to 210. Let's just mark that all the way around to 210. Right. Now I want you to see from 210 to 300, it remains constant. So I'm going to continue with that and I'm going to actually physically draw in a nice dark arc with my pair of compasses. I don't need to draw that in freehand because the point of the compass is in, it's set correctly. Okay, from 300, it then goes back to its original position. Okay, so I need to go to 330 over there. I'm going to draw in a line going across from 330. I'm going to take a line, an arc, going around over here. To 330. There it is. Okay. A bit of a waste of time. It was already on the mark. I didn't even need to draw that line in. And then it goes all the way back to 360, which is over there. Right, so from there, I need to draw some little, I like to use some little dots, just going around to signify where it all hooks up. Just using little dots I found works really, really nicely to get a nice curve which makes some sort of sense. There we go. It's continuing around over here. Once these little dots are in place, it's very much easier to sort of see whether you've got it in the right place, whether your curve is right or not. I'm just fixing that up a little bit, making it look a little bit prettier. Going in over there, and going all the way back down to where the wedge-shaped follower is. Right, once you've done that, you can then take your pencil and you can draw it in very nice and smoothly. Right, there we go. Going over those little dots. Nice thing with the little dots that I made there, I can pick my pencil up fairly easily at any point and still have a decent looking curve. You can also use your French curves more easily because you've got some sort of guideline to place it on. And it's easy to rub out those little dots that I've made. There we go. See, I picked up my pencil there. I can pick it up at any point that I want and continue from that point because I've got something to go on. There we go. There is the diagram, and you need to then write cam profile up here. 2 little construction lines and write in cam profile. C-A-M profile. Right, there we go, cam profile. Make sure that you have cam profile written, cam displacement graph, displacement in millimeters, rotation in degrees, scale 6 millimeters equal to 30. Make sure that you've written in all of those degrees over there, very, very important. And make sure that you've hatched the thing and make sure that you draw in that arrow over there. Those are the things that you get marks for, so make sure that you've done all of that and also writing in the degrees over there. Cool, enjoy.